Hello, this is AP Classroom, Unit 7, Free Response Question Set B, Question 1. No calculator is allowed for this question. Okay, background information, again, they always put that in the beginning in AP Classroom, and we are starting right here. Oops, consider the differential equation dy dx equals xy cubed. On the axes provided, sketch a slope field for the given differential equation at the 9 points that are indicated. So basically we need to go in and just calculate the slope at each of these points. So if x is 0, then this product will be 0. So everywhere where x is 0, there is a horizontal little baby slope segment here. Also, wherever y is 0, that'll also give us a 0 slope. So that's going to pick up this one here and this one here. I guess maybe I should have used a different color to make these stand out. Oh well. All right, now we've got 4 points left. Right here at this point, 1, 1. 1, 1 in here is just going to make a slope of 1. And I kind of eyeball it over here to match up with here to show that slope of 1. At this point, x is negative, y is positive. Both are 1, so that's going to make this negative and a positive. So that's going to give us a negative 1 slope right here. This one down here, x is negative, y is negative. That's going to give us that positive 1. And over here, we will get a negative 1 slope. Okay, point values for this problem was worth 2 points. You got +1 for all of the 0 slopes. And you get +1 for other slopes. Okay. Part B now. I'm going to need some more space. They didn't give us very much space down here, so I'm going to scoot it up here and get some blank paper. So, Part B. Find d squared y over dx squared in terms of x and y. Determine the concavity of all solution curves for the given differential equation in quadrant 4. Give a reason for your answer. So, first part here. Find d squared y over dx squared. So second derivative. I'm just going to write this down up here. So we have dy dx, this is part B, equals xy cubed. We need to find the second derivative. So d squared y over dx squared. We are going to have to do a product rule here. First times the derivative of the second, which would be a 3y squared, times a dy dx, plus the second, y cubed, times the derivative of the first, which is just a 1. I'm going to substitute out this dy dx. So we have x times 3y squared times dy dx, which was xy cubed, plus we have a y cubed here. And cleaning this up a bit, we're looking at, this is 3x squared times y to the 5th plus a y cubed. I'm going to go ahead and factor out a y cubed here, and that's 3x squared plus, 3x squared y squared plus a 1. All right, now there's your second derivative, but it asks you now determine the concavity of all solution curves for the differential equation in quadrant 4. So in quadrant 4, x is positive and y is negative. Okay, that means if I look up here, this piece, this y cubed piece, will be negative. Inside of here, 3, that's going to be positive. Y is negative, I'm going to square it. That's going to turn positive, and then add 1. So all of this is positive, and this piece is negative. So d squared y over dx squared is negative or less than 0. So the solution curves will be concave down. All right, let's move on to part C. Part C is a little bit longer here. I'm going to grab another piece of paper. Maybe I can squeeze it in. I'll try and squeeze it in. Okay, part C here is find the particular solution to y equals f of x to the given differential equation with the initial condition f of 2 equals negative 1. So we have to find the particular solution, which means we're going to need to solve for y. So let's start off with dy dx equals xy cubed. And then let's separate out the variables. So let's see, we're going to have dy over y cubed equals x dx. And I'm going to rewrite this as y to the negative 3 dy is x dx. Anti-differentiate both sides. And here, we're going to add 1 to the exponent. That's going to make that y to the negative 2 and divide by the new exponent. So negative 1/2 out here. And then anti-differentiate this one. This is going to be a 1/2 x squared. Don't forget that plus c. I'm going to clean this up a bit over here. I'm going to rewrite this as 1 over 2y squared. That 2 is in the bottom, and that y squared went to the bottom. This is x squared over 2 plus a c. I'm going to go ahead and substitute in right now that initial condition, f of 2 equals negative 1. And that's going to give me negative 1 over 2 times a negative 1 squared equals x squared. So 2 squared over 2 plus a c. This gives me negative 1/2 equals 2 plus a c, which means c is negative 2.5 or negative 5/2. Either way, I'm going to write it as negative 5/2. Shush, there's my dog barking at somebody on the street. Sorry. How dare they walk by the sidewalk in front of our house, right? Okay. Sorry about that. Let's come up here, and I'm going to substitute in that c value. So that's going to give us, I'm going to go right back here to this line where we substitute, oh, actually it was this line where I substituted in. This one, sorry. Let's see, negative 1 over 2y squared equals x squared over 2 minus 5 over 2. All right, now, find the particular solution to y equals. So we need to take this equation, once we figured out that c, and solve for y. This is an exercise in algebra at this point. I'm going to go ahead and multiply everything by the common denominator, which is 2y squared. So when I multiply everything by a 2y squared, this left side becomes a negative 1. On the right side, the 2's cancel, and we're going to have x squared y squared. And on over here on this one, the 2's cancel, and I'm going to get a minus 5y squared. Again, solving for y, so I'm going to have to factor out the y squared here. And then divide both sides by that x squared minus 5. Okay? All right, now, don't get too panicky here about this negative up here when we take the square root of both sides, because this difference down here of x squared minus 5 could be negative, which then essentially makes this whole fraction positive. So don't freak out that that's negative in there when you take the square root of both sides. I'm just going to rewrite this first. If it makes you a little bit happier, you could write it this way. And then you're not seeing that negative, and then you're not quite so panicky about it. And now when you take the square root of both sides, don't forget the plus or minus. Okay, and then there's one last little thing to do here, is that in our initial condition of f of 2 equals negative 1, when you substitute in a 2 for x, you're supposed to get a negative y value here, which means that it's not plus or minus, but that it is the negative square root of 1 over 5 minus x squared. That's your y equation there. Okay, let's go back and pick up points. And I think I forgot to do the points on part B, so I'll go back and pick those up right now as well. On part B, you get 1 point for getting this second derivative. And it can be in any form, but you must have substituted out that dy dx. So any of these forms, those 3 lines actually would work for that second derivative. And then you're going to get plus 1 for your answer here, concave down with a reason. Okay, part C, your points here on this one. First I'm going to tell you this, you get 0 out of 5 if you didn't separate the variables. Okay, so that's real important to recognize that you have to separate the variables here. You get 1 for separating the variables. You get plus 1 for the dy antiderivative. You're going to get plus 1 for the dx antiderivative. You're going to get plus 1 for getting the plus c, and for using that initial condition. So there's 4 points there. Now, as I said, this was a ton of algebra to go through and solve for this. If you get to this final answer, there's that additional point is the final answer. But gosh, that's rough for that 1 point for all of this, especially because if you left it as plus or minus, you don't get that 1 point. You got to get all the way to read that negative to get that last point, and that's a little rough there. Okay, hope that helped. Thanks for joining. Bye.